What's at the edge of our universe? It's one of the most compelling questions you could possibly ask, one that humanity has been asking since basically the beginning of time. What's beyond the observable universe? What is the limits of our universe? Well, the answer is complicated, but we can discuss about some possibilities here, so let's start. What is the universe? To answer the question of what's at the edge of universe, we first need to define exactly what we mean by universe. If you take it to mean literally all the things that could possibly exist in all of space and time, then there can't be anything outside the universe. Even if you imagine the universe to have some finite size and you imagine something outside that volume, then whatever is outside also has to be included in the universe. If the universe is infinite in size, the universe, being all there is, infinitely big and has no edge, so there's no outside. But there's an outside to our observable patch of the universe. The cosmos is so old, and light only travels so fast. So, in the history of the universe, we haven't received light from every single galaxy. The current width of the observable universe is about 90 billion light-years. And beyond that boundary, what was in that past? It's hard to tell. The curvature of the universe. Cosmologists aren't sure if the universe is infinitely big or just extremely large. To measure the universe, astronomers instead look at its curvature. The geometric curve on large scales of the universe tells us about its overall shape. If the universe is perfectly geometrically flat, then it can be infinite. If it's curved, like Earth's surface, then it has finite volume. Current observations and measurements of the curvature of the universe indicate that it is almost perfectly flat. But it's not that simple. Even in the case of a flat universe, the cosmos doesn't have to be infinitely big. Take, for example, the surface of a cylinder. It is geometrically flat because parallel lines drawn on the surface remain parallel. That's one of the definitions of flatness, and yet it has a finite size. The same could be true for the universe. It could be completely flat, yet closed in on itself. But even if the universe is finite, it doesn't necessarily mean there is an edge or an outside. It could be that our three-dimensional universe is embedded in some larger, multidimensional construct. That's perfectly fine and is indeed a part of some exotic models of physics. But currently, we have no way of testing that, and even if the universe has a finite volume, it doesn't have to be embedded. The matter of the universe. When you imagine the universe, you might think of a giant ball that's filled with stars, galaxies, and all sorts of interesting astrophysical objects. You may imagine how it looks from the outside, like an astronaut views Earth, but it sounds impossible for there to be a finite universe that has nothing outside it. And not even nothing in the sense of an empty void, completely and totally, mathematically undefined. In fact, the universe is entirely, mathematically self-consistent to define a three-dimensional universe without requiring an outside to that universe. The particle horizon. According to some scientists, the edge of the universe is defined by something called a particle horizon, which is similar to the event horizon of a black hole. The particle horizon differs from the event horizon in that the particle horizon represents the largest distance from which light could have reached the observer by a specific time. The particle horizon, also called the cosmological horizon, the comoving horizon, or the cosmic light horizon, is the maximum distance from which light from particles could have traveled to the observer in the age of the universe. The particle horizon is the theoretical maximum proper distance we can see to at the current time. It is a spherical shell approximately 46.5 billion light-years in radius around the Earth. But it's important to understand that the edge of the universe doesn't exist in the way that you might think it does. Conclusion. But again, it's important to understand that the edge of the universe doesn't exist in the way that we might think it does. To understand what is at the edge of universe and what we can imagine by using sophisticated and complex mathematics solutions, That's one of the powers of modern cosmology, as it allows us to study the unimaginable universe. Thank you for watching my video. Please like, comment and share this video. Also subscribe my channel for more space videos like this.